value of any existing variables, like argc equals 1, and this is the value of argv. We can dereference that to look at that information. So now if I want to go, the idea is we're here at line 4, we want to go line by line to see what is happening. For example, after line 20, once we go into the while loop, that would be most interesting. I can type next to move to the following line. So right now we have executed ROS init, and now we're going to create ROS node handle. Instead of typing next, I can also type N. And when this node handle is created, actually 4 threads are opened, but we won't discuss why that happens. But we can also now begin to examine the value of N. We can use print as a key command to see what's going inside of N. So here, for example, this node handle will say it has a namespace called minimal nodes. And so far there's no callback queue, and everything is working fine. Clear the screen, go to the next line. Yeah, and so we executed line 10. If you don't remember what that looks like, we can come back here, and we have the publisher object. So again, here we might want to look at what that looks like. You can also just tab on that. And this would give you a hard to read set of informations here. If you know more about C++, you could try to access the substructures of the variable. So for example, by looking at this px value, right now it says we have a shared pointer, and then there's some information there. We could also try to dereference this, where you get another address, and you can try to dereference that again. Oh, not in this way. I apologize. We can also access pn and then pi underscore, where you get more complex information about the publisher. This will not be immediately useful for you, but I just want to give you an example of how we might be able to debug something like this. So now we are currently in line 11, where we're going to create the input float. So we can say next, and next on this, and then print. We can also just do a P4 shortcut and type in input float, where we see, hey, we have a structure and there's an element called data equal to 0. Again, I could just access that and immediately get that value. Now, we're about to enter a while loop. So here we might just want to put a breakpoint on this line 24. To do that, we can type break or just B for short, and then the line number 24. And then instead of saying next here, we can use continue or C for short in order to move to the next breakpoint. Okay? So this immediately takes us to line 24, and here we can try to see what is the value of this data at different iterations. If I do continue, it's going to move me through the loop again, and so I can then look at this value one more time and see that it has incremented. Now, the breakpoint I placed on line 24 is breakpoint number 2. If I want to remove it, I can say delete 2. And now, if I just say break, it'll give, delete 3. I was expecting a list of the breaks, but that is not it. If I have removed that break. If I just say continue, it is running around the loop, and then that value would have been larger. Let's try that one more time. Minimal publisher, just run start and continue without any breaks. And we don't see anything over here on minimal subscriber because we changed that namespace from before. If we do sleepy minimal publisher, we will see something print on this side. Now, instead of saying start, because start stops at the main loop, we can do run, and run won't stop in main. It will just continue until it finds a breakpoint. And in this case, we have not inserted any. So it'll run through the while loop consistently, and then the subscriber can receive that information. So this is one way of running GDB. The interface is not nice, but I want you to be able to understand how debugging takes place at the lowest level. This kind of knowledge and the ability to master this technique is critical to be able to understand and debug complex programs. At a later time, I might show you how to debug similarly through Emacs or other graphical user interfaces. Now I can stop a GDB with Control-C and use Q for quit, and also kill my subscriber and my ROS core over here. Okay, and certainly there are many other IDEs for ROS. You can interface with Emacs, with Vim, with Qt, with NetBeans, Eclipse, and there's a pretty new IDE called RoboWare developed here in China that provides really nice functionality specifically to ROS. The Qt plugin also is very nice, and both of these are under heavy development. I would encourage you to first understand how creating packages, creating launch files, editing the CMake lists text file works, and how debugging works before you use an IDE, so that you have a solid grasp of the low-level details of ROS and the Linux system, and then you can use this at a later time to save you time on those further edits. There's also the ability to debug in Python. I won't go into detail for that, but I do want to show you a basic overview of this. There's a program called PDB, or an extended version of that, IPDB, that is useful to debug Python scripts. You can say sudo apt-get install python IPDB to get that code or that binary. And then when you have a particular Python code, you can say import IPDB, and then in a given line, you can say IPDB.setTrace wherever you want to stop, and it'll work very similarly to GDB as I just showed you. Also for Python, you can use a standard Python editor or the more rich IPython, and other IDEs like Spider or PyCharm. Debugging can also be done inside launch files. Again, I won't go into details right now, but I do want to tell you that it can be done. You can use GDB, IPDB, memory leak, Valgrind software, all inside launch files. We will normally use arguments inside nodes to turn debugging on and off. This is a really nice ability to have. And it needs to be used with if and unless fields and a launch prefix field. where it might look something like this. I would create an argument called debug, set it to false by default, but then say if the user in the command line sets debug to true, then create an argument called gdb argument, and then run a new terminal with gdb on it and pass any command line arguments to it. Okay, so the unless is if that is not the case, then we have nothing here. But then in your node you might have minimal debug, minimal nodes, minimal publisher, and then here you have launch prefix with the value of gdb arg. And so if you say debug equals true, then this term would come right here and a new terminal would start. This would be the way to launch with a command argument for a launch file or even for a node. Debug : equals with your value, in this case a boolean, true or false. And finally, one more tool to introduce to you is ROS bags. They allow you to record and also play topic data. This is going to be extremely useful for debugging complex systems or saving time when you want to run something and just analyze the data. ROS bag allows you to choose what topics to save. Today we just have a node with one topic, but there are going to be times where you might be working with 10, 20, 30, 40, 50 topics at a time, and this will allow you to choose which ones, which data do you want to save. This creates a bag file, sorry, not gap, but bag, where the topics are recorded with timestamps. And ROS bag will save the files by default in the current directory. In fact, let me come here and we can say something like ROS bag help. And so here you can see that we can play a ROS bag or we can record a ROS bag. For more details on recording, the usage is ROS bag record and then any number of given topics, along with other functions. For example, the name with which you want to save that file, or a maximum duration for a bag file, or a maximum size for a bag file. In the same way, we can also choose how to play it in different ways. ROS bag play with a pause, where you can start it at a later time by pressing the space key, or you can use a particular frequency to publish the clock, or you can ask it to loop over and over again in case you want to see data around the clock, or you can select specific topics from the whole set of topics as well. When we want to record data, we can always finish the recording by pressing Control-C. Okay, so here we can then play the data and check any results through RQT console or RQT graph. So here's an example of how we can do this. Let's bring this over here. Let me open a few windows. So let's start ROS core at the bottom. Let's do a ROS run, minimal nodes, minimal publisher. Let's do the sleepy version. Okay, so we know that we have these topics, and so here we can say ROS bag record topic 1. Sorry, I wrote that wrong. Okay, so now we're subscribing to this topic and we are recording with this particular name. So we can let that run for some time and then kill it with Control-C. and then play this one more time using ROS-back play. By the way, it just recorded it to the local directory with this name, so you could maybe copy it. And here, for example, we can say ROS topic echo topic 1. Right now it's running because we are running this node. Let me kill it. Yeah, this time there's nothing here, but if I say ROS-back play bag file, you can see that we get the time and the duration. And then here in the echo, we can get this data. We just ran for 12 seconds, and so we got this data so far. We can also do that with a loop. Okay, so this would go up to 12 and then start again. So you can see how that data is going up, 26, 30, and then start again from 18. Okay, so as you can see, this is very, very useful, especially when the system is more complex. This concludes our presentation for today. We went through details on how to publish, how to subscribe, the meaning of node handles and namespaces, as well as callbacks and spin cycles, and how we can integrate that into launch files, and further just looking at different tools that let us look inside the network and its performance, and finally how to record and play some of that data. Chapter 1 has a 4th section, which is a very practical section. This homework 2 will basically walk you through section 1.4. You can even skip reading section 1.4 and just directly read the homework, because the homework is primarily a repetition of section 1.4. It will help you to make sure you've downloaded and compiled minimal nodes and analyzed their performance. And later it introduces you to 2 new nodes, the simulator node, the controller node, mimicking a very simplistic way in which a robot might behave. And for your homework, you have to do some analysis on these 2 new nodes. So it will test your knowledge about ROS tools, like ROS node list, ROS topic, and even ROS plot and ROS graph. ROS plot we didn't look at so far, but it will be introduced in the homework. I hope you're excited. This will be a long homework, but I also think that you will find it very useful in helping you master the basics of nodes, topics, publication, and subscription. Next week, we will start learning about other kinds of communication like ROS services and actions. Thank you very much.